Good morning, everyone. Today we are going to continue with chapter number 6 from the subject software architecture and design pattern. Chapter number 6 is grasp design principles. Okay. So in last sessions we have seen about what is grasp, what are the responsibilities in this pattern. So it stands for general responsibility assignment software patterns. There are several patterns under grasp. Okay. So from that we have seen creator pattern. Okay, then we have seen the example for creator pattern. Then we have seen the information expert pattern, example for that pattern. Then we have seen about low coupling pattern. Okay, we have seen what is low coupling and what is poor coupling. Okay, in last sessions we have seen about controller pattern. What is controller, how we can add the controller in our design. Then what is blotted controllers, we have seen that high cohesion. What is high cohesion and low cohesion, difference between high cohesion and low cohesion. And in last sessions also we have seen polymorphism, that is how to handle related but varying elements based on the element type. This is the problem definition for polymorphism pattern, that is how to handle related but varying elements based on that type of that element. So for that solution is polymorphism guides us in deciding which object is responsible for handling those varying elements, which object is responsible for that handling those varying elements. Polymorphism guides us to decide that. Okay, so benefits of that pattern is handling new variations will become easy in this. So here you can see the example. We are having one class shape. Okay, this figure you can see we are having one class shape, having one methods, and generalized two classes circle and triangle. Here the get area method varies by the type of that shape. If you want to calculate the area of that shape, then we have to decide which shape it is. Okay, the type of shape, your type of shape is the varying element, so we have to assign the responsibilities to that subclasses. Okay, here you can see the subclasses circle and a triangle, also having methods get area. So whenever we are going to calculate the area, okay, here you can see by sending messages to the shape object, here a call will be made to the corresponding subclasses or sub objects of that classes. Okay, circle and triangle. Whenever we are going to calculate the area of that shape, which shape we have to calculate the area for that, it may be circle or it either triangle. Okay, so this is about polymorphism pattern. Now we are continuing with pure fabrication pattern. Okay, fabricated class or artificial class. Here, artificial class is included in pure fabrication. In this, assign set of related responsibilities that doesn't represent any domain object. We have to assign set of related responsibilities that doesn't represent any domain object. Whenever we are going to assign the responsibilities to that class or object, we have to assign that responsibilities to that artificial class. Okay, then it provides a highly cohesive set of activities. Behavioral decompose, it implements some algorithms for that. For example of this pattern is like adapter pattern, strategy pattern we have seen in these design patterns. Okay, what is adapter and what is strategy patterns. So benefits of pure fabrication is high cohesion, low coupling, and reuse of these classes. Okay, so here you can see the example for pure fabrication. Suppose consider we are having one class shape class. Okay, if we must store the shape data in a database, we have to store the shape database in that database. Okay, then if we put this responsibility in shape class, there will be a many database related operations, thus making shape incohesive. Okay, if there are several responsibilities in for that shape class. Okay, so there will be many database related operations for that shape class. If we put this responsibility into one single class, it will make incohesive for that shape class. Okay, so for that we have to create a new fabricated class db store for that shape class. Okay, so we have to store the database in another class, that is it's also called as fabricated class, or here you can see fabricated or artificial class we have to create. Consider like DB store, which is responsible to perform all database operations. For that performing database operations, we have to create new fabricated class. Previously, what we are doing, we are setting or we are allocating all the responsibilities to that single class like shape class, and we are performing all the database related operations in that for that shape class in for single class. Okay, so we are storing all the data in the database for that shape class. But if we use for that, what happen if we are doing that or performing all the database related operations, it will making incohesive. Shape class is incohesive. For to avoid that, we have to create a fabricated class, that is artificial class also. That is, if we create an artificial class, what it will do, it will make or it will provide high cohesion. Okay, low coupling, high cohesion. Then it is responsible to perform all the database operations. If you create that database class separately, it will provide or perform all the database operations separately. Similarly, we have to create one interface here. Similarly, log interface, which is responsible for logging information, is also a good example of our pure fabrication. We have to maintain the log information or log interface for that classes. Okay, this is all about pure fabrication. The next one is indirection pattern. What is indirection pattern? What is the problem definition for that? How can we avoid a direct coupling between two or more elements? In previous patterns, we have seen that like low coupling, we have to couple the number of classes to avoid the redundancy between that. Okay, so here in indirection pattern, how we can avoid a direct coupling between two or more elements? If there is a direct coupling between that elements, how we can avoid this? Here, for that, indirection introduces an intermediate unit. It will introduces an intermediate unit will be there for communicating between these units or communicating between this number of elements, so that the other units not directly couple. Okay, so indirection pattern will provide one intermediate unit to communicate between two classes. Okay, so what is the benefit of that? Low coupling. Okay, examples of that indirection pattern: adapter, packet, and observer. Okay, this is the indirection pattern. You can see the example of indirection pattern here. Polymorphism illustrates indirection. Polymorphism, we have seen that. Okay, here you can see the class employee. Employee provides, here employee acts as a level indirection. Here employee provides a level of indirection to other units of the system. Here you can see the salary. If you want to get the total salary, you will get that salary, total salary of that all the employees. Or if you want to get the particular sorry, if you want to get the salary of particular employee, then we will face that details from that employee class. Okay, so that means employee acts as a level of indirection, that is low coupling here. Okay, this is all about indirection pattern. Then next pattern is protected variation. Protected variation. Your problem definition is how to avoid impact of variations of some elements on the other elements. Here, variation of elements means variation or change in that element will affect on other element. If that elements are dependent or interdependent on or dependent on one another, if we are going to change the data from one element, data for one element, it will affect on other. So how to avoid that impact of variation of some elements on the other elements? So this is the problem definition for protected variation. So it will solution for that, it provides a well defined interface. It provides a well defined interface so that the so that there will be no effect on other units. For that, protected variation provides interface. Okay, interface to avoid impact of variation of elements of one another. Okay, so it provides a flexibility and protection from variation. It provides flexibility and protection from variations. It also provides more structured design, like you can see the example: polymorphism, data encapsulation, interfaces. Okay, so in protected variation, to avoid that variation of elements and the effect of that change elements on one another, it provides a well defined interface. Okay, so that it provides the flexibility and protections, it provides more structural design. Okay, so this is some references for this chapter. Okay, so in this way we have finished the chapter number 6. Okay, so that's it for today's session. Thank you.